Welcome again, student. Now we'll be discussing on the part 3 of this chapter 1 with the problem number 4. Okay. Determine the greatest number which will divide 4, 4, 5, 5, 7, 2, 6, 9, 9, leaving remainder 4, 5, 6 respectively. That means a number which on dividing to 4, 4, 5 it will leave remainder 4, 5, 7, 2 it will leave remainder 5, and 6, 9, 9 it will leave remainder as 6. Okay, we have to find the greatest number which on dividing these three numbers will leave the remainder 4, 5, 6. That means just think about that number. If it divide this number and leaving remainder 4, 5, 6 respectively, mean if you subtract 4, 4, 5 by 4, 5, 7, 2 by 5 and 6, 9, 9 by 6, mean that number will leave no remainder at all, isn't it? Now is leaving remainder 4, 5, 6, but if you subtract these three number by these three remainders, mean it will leave no remainder at all. Now if a number which can divide all these three numbers without leaving any remainder, what is that number? It is the LCF of those three numbers. Clear? Now the thing is that you have to find the LCF of these three numbers after subtracting by 4, 5 and 6. Okay, now solution for this: when 4, 4, 5, 5, 7, 2 and 6, 9, 9 divided by a number which is leaving the remainder as 4, 5 and 6 respectively, that means therefore the number should be divisible to 4, 4, 5 minus 4, 5, 7, 2 minus 5, 6, 9, 9 minus 6, or 441, 567 and 693, leaving no remainder. Clear? Thus the required number will be the LCF of these three number. Now let us find the LCF of these three number. As in the last part we have discussed how to find the LCF of three numbers. What we have to do, first we have to find the first two numbers, and then the LCF we are getting from these two numbers. Again find the LCF with regard to the third number, and whatever LCF we are getting, that will be the required LCF of all these three numbers. Okay, now let us take the first two numbers, 441 and 567. Which is greater out of these two is 567, isn't it? Now we will take 567 as A and B as 441. Now applying EDA successively to these two numbers, taking dividend as 567 divided by 441, you will go with 1, leaving remainder 126. That means 567 equal 441 multiply 1 plus remainder 126. Now again, since remainder is not 0, you have to again proceed ahead, dividing 441 by 126. You will go with 3, leaving you a remainder of 63. Okay, now again, since remainder is not 0, you have to proceed ahead, dividing 126 by 23. You'll go with 2 is 126, and here last we find that remainder is 0. Hence this last divisor 63 will be LCF of these two numbers. And now let us take this 63 and the third number with the 693 and find the LCF between these two. Okay, A will take by the bigger number 693, B by the smaller number, and then again proceed with the EDA or Euclid division algorithm. You will find that 693 is equal to 63 multiplied by 11. You can exactly divide 693 by 63, going with 11, leaving no remainder at all. Hence, this 63 will be the HCF of these three numbers. That means the required number will be 63 itself, and if you try to divide those three numbers with its given equation, you'll find that the remainder you will get a remainder as 4, 5 and 6 respectively. That you can try by yourself. Try to divide whether you will be getting 4, 5, 6 as remainder or not. Okay, but if you try, you will get as 4, 5, 6 to be the remainder. Okay, next we'll move to the problem number 5. Using Euclid division algorithm, state whether the number 47 and 149 are co-prime or not. Okay, what is co-prime? The number, let us state a simple number, 2 and 3. 2 is a prime, 3 is prime, 5 is prime, 7 is prime. Now, out of these 3-4 numbers that we've taken, now is there any number which is divisible to 2 and 3, or 5 and 7, or 7 and 9? Is there any number which can divide them? No, because they are prime, there is no other number which can divide them. Now here randomly we have taken, they have asked us to find 47 and 149. Okay, 47 and 149, they asked us to find whether they are co-prime or not. Means we have to find out whether the HCF between these two numbers is 1 or not. If the HCF is 1, that means they are the co-prime. There is no other factors other than 1. Okay, now let us take these two numbers and find the HCF, taking A by bigger number, B by smaller number. 149, if you divide by 47, you'll have to go with 3, you'll get 141, remainder is 8. Okay, and then again take 47 as the dividend. 8 multiply 5 is 40, leaving remainder 7. Again, since remainder is not 0, you have to proceed ahead. 8 divided by 7, you will go with 1 is 7, leaving remainder 1. Again, 1 you divide to 7, you will go with 7, leaving you a remainder 0. Okay, now what will be the HCF here is 1, because 1 is the last divisor here. Okay, HCF of these two numbers will be 1s. That means these two numbers, they are the co-prime. Clear? Here in this Euclid division algorithm, you have proceed like this. 149 is called 47 multiply 3 plus 8. 47 multiply 3 plus 8. 47 is called 8 multiply 5 plus 7. 8 is called 7 multiply 1 plus 7. Again, the last step, 7 is called 1 multiply 7 plus 0. Clear? Okay, this is the we have been able to say that these two numbers, they are the co-prime, and hence we'll proceed ahead with the problem number 6. Using Euclid division algorithm, find whether the following pairs of number they are co-prime. Same thing you have to do as this question number 5, but here is given, the first one is given to be 272 and 1032. Okay, we check whether they are co-prime or not. Co-prime means each of these number is not exactly to be a prime number. Okay, 272 is not a prime number, 1032 is not a prime number, but when we consider them, both of these two, when we consider both of these two numbers, whether they are the co-prime or not, one related to the other. This number is co-prime or not related to the second number. If you able to find, if you find out, if you can find out that the ACF is 1, then they are co-prime, otherwise they are not co-prime. Now let us proceed ahead with this. Let us take A by a bigger number and B by a smaller number. When you divide the bigger number by a smaller number, here I've shown you on the right side how division is going on. 272 divide to this number, you will go with 3 is 816. Remainder will be 216. Since remainder is not 0, you have to proceed ahead. 272 divide by 216, you will go with 1, leaving you remain 56. 56 divide to 216, you will go with 3, remainder is what you will get 168, giving you remainder 48. And then 48 divide to 56, you will go with 1, is 48, giving you remainder 8. 8 divide to 48, you will go with 6, 8 6 48, giving you remainder 0. Okay, here the EDA process I've shown you here. 1032 is equal to 272 multiply 3 plus remainder 216. And the same thing with this also, you can just look from the division that I've done on the right side how this dividend is being expressed as. Since here at the last step remainder is 0, hence the ACF will be the last divisor, which is 8. Okay, now ACF is 8. Can we say that these two numbers are co-prime? No. Why? Because the ACF is other than 1. Clear? If the ACF is other than 1, then they are not co-prime. Hence here also these two numbers, they are not co-prime since the ACF is not equal to 1. Next, with the second from here is 847 and 2160. Taking A by a bigger number and B by a smaller number, when you divide the bigger number by a smaller number, 847 you go with 2 is 1694, giving you remainder 46. 466, 87 multiply 2 plus 466. Then you take this 847 divisor as the dividend. You take this divisor as the dividend and this remainder as the divisor. You just shift this place. See, 847 you shift this place. 466 you shift here as the divisor. Now if you divide this, you will go with 1, giving you remainder 381. Again do the same thing, shift 466 to the left, 381 here, 381 you have to go with 1, giving you remainder 85. Again proceed, 381 here, 85 bring this side, 85 you will go with 4 is 340, giving you remainder 41. Then 41 divide to 85, you will go with 2 is 82, giving you remainder 3. 3 divide to 41, you will go 13 is 39, giving you remainder 2. Okay, now again 3 divide by 2, you will go with 1 is 2, giving you remainder 1. And lastly 1 you divide 2 divide by 1, you go with 2 is 2, giving you remainder 0. And what is the divisor here? It is the last divisor, which is 1. Hence we can say that these two numbers, they are the co-prime. It's clear to all of you? Now the next number 3 and 4, you try to do it by yourself in the same way as we have shown you on the first and second one. You try it by yourself to find out whether they are co-prime or not. Okay, now we move to the next number, which is on the number 7. Find the ACF of 135 and 225 and express it as a linear combination of 135 and 225. Okay, how to express as linear combination we'll see here. the solution that I have solved for you. Same thing, we will find the ACF first of these two numbers. We'll proceed ahead by taking A by bigger number, B smaller number, then divide the bigger by smaller. 135 go to 1 is 225, not 225, 135. Then remainder you will get 90. Then 135 divided by 90, you will go with 1, giving you remainder 45. Then again 90 divided by 45, you will go with 2, giving you remainder 0. Now what is the last divisor here is 45, isn't it? The ACF will be 45. Now how to express as linear combination? To express as linear combination, you mark this step, the first step, second step, the third step. Okay, if there are 4 steps, you mark the first step, the second step, the third step. You leave the last step, you leave it. Okay, you leave the last step. You'll go to first step, second step, third step. If there are 4 steps in the algorithm, if there are 3 steps, then you mark only the first and second step. Okay, now start from the second step. Starting from the second step, now ACF is 5. Okay, 45. Then you take this 45 from step number 2, transpose this 90 multiply 1 to the left. 45 will be equal how much? 135 minus 90 multiply 1. Clear? From this equation number 2, from this step number 2, you bring this 90 multiply 1 to the left. On bringing this, when you transpose to the left side, this plus sign will change to minus sign, isn't it? Therefore 45 will be how much? Will be 135 minus 90 multiply 1. This is we are getting from step 2. And the next step, what we'll do, you'll keep this 135 and this 90. You see in step 1 remainder we are getting 90, and this 90 will be how much? Will be 225 minus 135 multiply 1. Instead of 90, this 90, you will substitute the value of 90 from equation number 1, which is 225 minus 135 multiply 1. Again this 1, 90 multiply 1, this you keep as it is. You just change the value of this 90. Okay, 90 from 1 you get 225 minus 135 multiply 1. Now the next step, what you will do, you will multiply this 1 to 225 is 225, 225 multiply 1, isn't it? Minus with plus is minus. Then minus with minus is how much? Plus. 1 multiply 135 multiply 1. Again you will get the same thing. 135 multiply 1. Okay. Now here 135 is here. 135 is here. This is plus, this is also plus. Plus with plus, 135 plus 135 is 2 multiply twice of 135, or you consider 2 times 135. If you have here 135 plus 135 plus 135 plus 135, then what you will do, you will write 135 multiply how many times it occur? If you occur 3 times, you will multiply by 3. If you occur 4 times, you multiply by 4. Here how many times it occur? 135 plus 135, this means 2 times 135 multiply with 2. Now minus this 135 you have taken, minus 125 is only once, isn't it? Multiply only once. Now 135 multiply 2, what you will do, this sign minus you change it to plus. If you change to plus, you take this minus with minus 1, because if you change this sign minus to plus and then you make it 225 multiply with minus 1, what you will get here, if you multiply you will get the same thing only, isn't it? Minus with plus, again minus, 225 multiply 1 is 225 multiply 1, same thing you will get. Just change the value of, change the sign of this 225 from minus to plus and this one from plus to minus. Just interchange side. Okay, because both of these number you have to multiply. If you multiply two number, if one is plus, other is minus, you will get minus only. If minus is with 225, or if minus is with 1, if you multiply, you are getting the same, minus of 225. Okay, now why we are keeping this, why we want to change this, because we want to express as a linear combination. 135 multiply 2 plus 225 multiply minus 1, you can write as 135x plus 225y, where x is 2 and y is minus 1. Okay, this is the linear, how to express as a linear combination. That means 45, this HCF 45 we can express as a linear combination of 135x plus 225y, where x is 2 and y is minus 1. Okay, now if you want to find out what is the value of this 135x plus 225y, you try to find out by doing a rough in your rough copy. 135 multiply 2, how much you will get? 270. Okay, 270 minus 225, you will get how much? You will get 45 only, isn't it? 45 is called this much, but this much, if you substitute the value of x and y, you will get what we will get. You will get the same value as 45 only. But here we have expressed this 45 as a linear combination of x and y, where x is 2 and y is minus 1. Okay, next, number 8 also is the same. The problem is the same thing. You have to express as a linear combination, but here we have to find out whether this combination is unique or not, and if not, then we have to express one more linear combination of these two numbers. Okay, let us proceed with this. Same thing, you have to find in the beginning, you have to find the HCF of these two. I need not discuss this finding the HCF, because so many times I've discussed for finding the HCF. I think you by now you are able to do it by yourself. Now the HCF of these two numbers we have got to be 63. Now 63 we have to express as a linear combination of 225 and 135. Okay, now 63. Now in EDA process here there are 3 steps. Therefore, you will mark only the first and second step. The last step you will leave it. Okay. If there are 4 steps, you will mark only the first 3 steps. You leave the last step. Here, because it's only 3 steps, you will mark only the first and second step. Okay. Now starting from the second, going backward. Okay. Now 63 is the HCF. 63 will be how much? Will be 567 minus 126 multiply 4, isn't it? 567 minus 126 multiply 4. But from step 1, how much is 126? 126 is 693 minus 567 multiply 1, isn't it? Instead of 126, you will write 693 minus 567 multiply 1. Okay, substituting the value of 126 from step 1. Now this 567 you write as it is, minus, then 4 multiply with this 693. see this bracket, 4 you have to multiply with this, and you have to multiply with this also. 4 multiply 693 is 693 multiply 4, then minus multiply with minus is plus. 4 multiply 1 is 4, that means 567 multiply 4, 693 multiply 4. We have distribute this 4 to 693 and 567. Okay, now 567 is here, 567 is here. Now 567 is, this is plus, this is also plus. This is 4 times of 567 plus 1. That means it will be how many times? 5 times, isn't it? 567 multiply 5 times minus 693 multiply 4 times. Now the next step is that you have to change this minus to plus. Again you'll carry this minus to make the 4 to minus 4. 567 multiply 5 plus 693 multiply minus 4. Hence you will get 567 multiply x plus 693 multiply y, where x is 5 and y is minus 4. Now 63 is equal 567x plus 693y. This is the first linear combination. Now we want to find whether this is unique or not. What you'll do, what are those two numbers which is given in question? If you look in the question, is given 693 and 567. Okay, now what you'll do, 693 and 567 you multiply and you add and subtract. Adding and subtracting these two numbers, the product of these two numbers in equation number 3. This 567, 693. Okay, 567 multiply 5 plus 693 multiply minus 4. This is equation 3. You add and subtract. Now if you, in any equation, if you add and subtract, what you will get? You will get the same value only, because adding by same number and subtracting by the same number mean those two numbers which you add and subtract will cancel each other, isn't it? Will cancel each other. This means you will get 0. This means you will remain as it is. Mean this thing, if you add and subtract also, you will remain, what you will get, will remain this same equation only. This equation 3 will remain as equation number 3 only, because you are adding by the same number and subtracting by the same number. But it's not just adding and subtracting. We need to simplify it a little bit further so that we can get a linear combination. Okay, then here in this step 3, this 63 equal 567 multiply 5 plus 693 multiply minus 4. Okay, this up to here I've just copied from the step 3. Now you add with 567 multiply 693, subtract with 567 multiply 693. Okay, now what you'll do, 567 multiply 5 plus, you take this to the, you bring closer to this 567, because here 567 isn't it? You bring it closer. You are not bringing to the left or to the right. Remember, is on the same side. This means there will be no changes in sign. Okay, this plus 567 multiply 693. Take the first two. Okay, first two, and you just bring close to these two. 567 plus 6 multiply 693, and then the second two numbers 693 multiply minus 4, 693 multiply minus 4 plus with this 693 minus 567. Why we are bringing interchanging here? Because this 693, the thing is that you have to group them in such a way that you will be able to take common. See, look carefully. 567 multiply 5, 567 multiply 693. 567 is common here, isn't it? And here also this 693 you should take common. You should be able to take common. That means you will write 693 multiply minus 4 plus 693 multiply minus 567. Okay, whatever, if you bring this plus also, you will getting the same thing, because plus minus is minus only. Product of these two numbers will be minus of whatever you are getting, isn't it? Therefore, by bringing this plus sign will not change anything here. Remember that because this plus 693 you just multiply with minus 6567. Okay, the thing is that you group them in such a way that you will be able to take common 693 693, 567 567. Okay, now you take this 567 is common within this first two. See, this is the first term, this is the second term, this is the third term, this is the fourth term. Between the first two terms, 567 is common, and you will be getting 5 plus 693. And then you take common between the last two, you have this plus sign. 693, 693 is common, you will take 693 common, then you will have minus 4 plus minus 567. Okay, now 5 plus 693 is 698. 567 multiply 698, then plus 693 multiply with how much? Minus 4 plus minus 567. Plus minus is minus. 567 minus 4, both are minus. Minus minus you have to plus, then 567 plus 4 is 671. Sign will be minus sign because you are adding two negative numbers. Okay, therefore therefore you will get how much? If you take the 698 as x minus 671 as y, you will get 567x plus 693y, isn't it? Take this 698 as x, 671 as y, you will get 567 plus 693, 567x plus 693y. This is, as you mark this as equation number 4. Now you see in equation 3, 5675, 693 minus 4, 567, 698, 693, 671 is different. Linear combination is different. X and y are different. Even though 567, 693, here also 567, 693, x and y, here also x and y, but here x is different from in this first linear combination we are getting 5 and minus 4, whereas in the second linear combination we are getting x is 698 and y is 671. Hence the equation number 4 represents another linear combination. Hence we can say that the equation number 4 represents another linear combination. Hence the value of x and y, they are not unique. Okay, it's clear to you? Please listen again carefully with this, because this is a little bit hard for you to understand. You look carefully and try to watch the video carefully so that you are able to grasp what we have discussed here. Okay, for the time being we'll stop here and we'll discuss again the next part on the next class. Okay, bye to all of you.